Example 3. Which relation is linear? Create a table to justify your answer. A new car purchased for $24,000. Each year, the value of the car decreases by 15%. The value is related to the time. So what we see as the years progress, as the years increase by 1, the value of the car decreases by 15%. But as we look at it from a money perspective, the first year is 0 years, you buy a $24,000 car. When the car decreases by 15%, so really this is a side calculation, 15% of 24,000, that is 3,600. So that's how much you lose in value. So you have to subtract 3,600 from 24,000 to get 20,400. And then you can repeat the process to get this value of the car. What we notice as the years increase by 1, the value that we lose on a car actually decreases. So there is a $3,600 decrease in that first year. And then there is a $3,060 decrease in the next year. And between the second and the third year, there is a $2,601 decrease. Is the value of the car linear? No. There is not constant change. So the change is not constant over here. However, let's go on to the next one. For a service call, an electrician charges $75 for a flat rate, plus $50 for every hour that he works. The total cost for the service is related to the time. So after 0 hours, in other words, he shows up at the door, she, the electrician, is charging you $75. And for 1 hour, it is really $75 plus $50, which is $125. And then 2 hours is $75 plus two $50s, which is $175. And we can carry on in this order to get how much an electrician costs. As time increases by 1 hour each, from 1 or 0 to 1, 1 to 2, 2 to 3, 3 to 4, the amount of the cost goes up by $50. So since the rate of change is constant on both, this is a linear function. Example number 4. A water tank on a farm holds 6,000 liters. Graph A represents the tank being filled up at a constant rate. Graph B represents the tank being empty at a constant rate. Do these both graphs represent linear? Do they form lines? Now it's a linear function, so they have to form a line that passes the vertical line test. And obviously, I think that both of these are lines. Identify the independent variable and the dependent variable. The independent variable is time. And there's two reasons for that, because time's on the horizontal. However, also, does the volume inside a tank depend on the time? Or does the time of the world depend upon the amount of liquid in this one tank? Obviously, the dependent variable has to be volume because volume depends on the amount of time it takes. Now, here is an interesting notion, the rate of change. That is, how much does, really the rate of change should say per 1 minute, how much does the volume change? So in this first graph for A, and what I can see here is that the volume, really what we're looking for is the change of volume over the change of time. And if I start from 0 and fill it up, I notice that my volume changes by 6,000 liters. My time goes from 0 to 120. So my rate of change is 6,000 liters divided by 120 minutes. If I divide both top and bottom by 120, I get 50. That numeric value 50, 6,000 divided by 120, and I'm going to keep my units. Look, I'm just going to keep these units. So I deal with the numbers and I keep the units, which is liters per minute. And that is, for A, I could say, filling up, I fill up 50 liters in 1 minute. Whereas graph B, well, graph B, my rate of change is going to be my change of volume over the change in time. Now, on the graph, what we may see is my change in volume is, I'm going to say negative 6,000 because we start off at 6,000 and the volume goes down to 0, and that is in liters. And the amount of time is 50 minutes. So again, I take 60,000 divided by 50, and what I get is the rate of change is minus 120 liters per minute. That is, I lose 120 liters in 1 minute.